Problem 4. We have 10 moles of an ideal gas. Described a carnot cycle between temperature T1 equals to 400 C and T2 equals to 60 C. When I say we have a carnot, you know we have T high and T low, and we have Q hot, Q cold out, and we have a work omega done by the engine. So here, first of all, we have T high equals to 400 C. We have to put it in Kelvin plus 273. We get 673 Kelvin. And we have T low or T cold equals to 60 plus 273 equals to 333 Kelvin. Okay, we give you know the carnot cycle, we have two isothermal processes and we have two adiabatic processes. Okay, it's like this. Let me, if you put PV diagram, we have P and V. In general, we have the point A to B, from B to C, from C to D, and from D to A. So AB and CD are isothermal, and BC and DA are adiabatic. And you know, when I say T high and T low, T high is for the point A and B. So TA equals to TB equals to 673 Kelvin. And TC equals to TD equals to 3 Kelvin. We can delete this one to gain space. Okay. Okay. I give you VA equals to 2 times 10 minus 2 m cube. And we have VB must be greater than VA equals to 4 times 10 minus 2 m cube. And I give you VC equals to 5 times 10 minus 2 m cube. Okay. First of all, part A, calculate Q received by the gas during a cycle. In general, you have to know very well how this kind of cycle of carnot machine functioning. You know, the operation of a carnot machine will be between Q cold and Q hot. You have one Q hot in the system. In general, Q hot is QAB, and Q cold is QCD. Where in the operation, in the process AB, you have Q hot added to the system, and during CD, we have Q cold out of the system. Okay, when I say C, it means cold. And between B and C and dA, we don't have Q, where Q equals to O because we have adiabatic process. Okay, calculate Q received. It means Q hat by the gas during a cycle. I need to calculate Q hat. You know, in the case of AB, you have to know the equations. We have an isothermal process. In general, uh, you know, we have QAB, or you can say during this operation between A and B, it's isothermal. Okay, and in this case, we have delta E equals to O because delta E depends on the temperature. If T is constant, delta E equals to 0, equals to Q minus omega. Okay, here you can calculate, I need to calculate Q, but I don't have the value of omega. Let me write first of all, in this case, Q equals to omega. But if you know the expression of omega in the case of isothermal, you can write it directly. If you don't know, you have to calculate it, which is equal to the integral of P dV equals to the integral between the initial point A to the final point B, P dV, P equals to nRT divided by V equals to nRT divided by V times dV equals to nRT, R constant, okay, N is constant, R is constant, and T is constant between A and B. Integral of dV divided by V equals to ln V. Ln V final equals to ln VB minus VA. You can say directly ln VB divided by VA. Okay, this one is ln VB minus ln. Okay, if you want, we can write it directly. We have ln V between A and B, which is equal to N R T ln VB minus ln VA. Okay, equals to N R T ln VB divided by VA. You know, when we go from A to B, we increase the volume. The volume increases. In this case, omega must be positive. And you know, in the case of Q hat, it must be positive. So, as VB is greater than VA, so ln VB divided by VA is positive. Here, I give you 10 moles. R equals to 8.31. T between A and B is given, which is a value of high temperature equals to 400 plus equals to 673, okay, times we can put it times ln VB equals to 4 times 10 minus 2 divided by VA, which is equal to 2 times 10 minus 2. We do the calculation to get the value of Q and omega AB. So it will be 38,783.8 joule. It's a QAB. We can put the answer here. Okay, so we get here QAB equals to omega AB equals to 38,783.8 joule. Maybe I can ask you if where is Q hat? You have to calculate QAB and QCD. And the positive one will be Q hat and the negative one will be Q cold. Okay, this is QAB. Second part, calculate the efficiency of the cycle. You know, in the case of carnot machine, the efficiency is maximum, which is equal to omega of the cycle psi divided by Q Q hat, or equals to 1 minus T T cold divided by T hat. When I say T cold, it means T low. T high, it means T high, or T hot. I want to calculate efficiency, which is equal to 1 minus T cold divided by T hot. The answer must be less than 1, equals to, it will be 0.5, or you can say 50%. Now we have to deduce the value of the total work. You know, we can use this formula directly. The total work of the machine, in general, omega of the cycle equals to omega AB plus omega BC plus omega CD plus omega dA. Okay, and Q total of the cycle equals to Q hot minus Q cold. And we can use this one directly to calculate omega of the cycle divided by Q hot equals to 0.5. So omega of the cycle, you have to deduce, it means you have to use this one directly, equals to Q hat 3873.8 times 0.5. We calculate the value. So the answer will be 19,381.9 joule. This is omega of the cycle. Next, we have to find the amount of heat lost. When I say lost, it means Q cold during a cycle. You know, to determine Q cold, here you have many methods. First of all, you can use E carnot. You know, E carnot. equals to uh, omega of the cycle divided by q hat, you can write also equals to 1 minus q q cold divided by q hat. You can use this one. It's a general expression of efficiency, but only in the case of q hat. In the case of Carnot machine, you can use this one and 1 minus T cold divided by T hat. So you can use this one. Also, you can use another expression, uh, delta E of any cycle equals to Q of cycle minus omega of the cycle. So we can equals to O. And Q of the cycle equals to Q hat minus Q cold minus omega of the cycle equals to O. So we can calculate Q cold absolute value, which is equal to Q hat minus omega of the cycle, which is equal to Q hat is QAB minus omega of the cycle equals to equals to 19,391.9 joule. We get here the value of Q cold, absolute value of Q cold. In general, it's a negative value, but when I put absolute value, you get a positive value. The answer will be 19,391.9 joule. It's a reasonable answer. Why? Because as we have a 0.5 efficiency, in this case, you will get 50% will be consumed as a work, and we have also a 50% will be consumed as a Q cold. Okay, so in this case, as you see here, we have Q cold is equal to Q hot. We have the same value. Determine from this data the volume at the point D. In the case of Carnot machine, you have a relation between the volume of each state, between VA, VB, VC, VD. You can apply this relation directly. Okay? In the case of Carnot machine, you can write directly VB divided by VA equals to VC divided by VD. Here I want to calculate VD, where VD equals to VA VC divided by VA VC divided by VB. Okay, equals to VA 2 times 10 minus 2, VC equals to 5 times 10 minus 2 divided by VB, which is equal to 4 times 10 minus 2. We can calculate its value here. We can eliminate this one and this one to get here 10 divided by 4 times 10 minus 2 m cube. Okay, be careful, you can use this one directly only in the case of carnot machine.